So what is the machine learning and how we can use this machine learning in this particular experiment? Okay, so let's understand first this. Generally, for this PyCaret, for regression, we use different data sets. Okay, so these data sets are available in this P by caret. Okay, so data sets are available inside this P by caret file or P by caret library. Okay, so this P by caret library contain some classification data set, regression data set, and clustering data set. Okay, so first of all, understand this classification, regression, and clustering. Okay, so when we talk about two classes, either that class will be of 0 or 1. Okay, we have to choose between these two choices. Let's suppose that we are defining 0 for cat and we are defining 1 for dog. Okay, and in a real time when we train the model, okay, we train the model, machine learning model, with such images of cat and dog. In real time when we provide any image of cat, this machine learning model classify classify which type of image is this. Okay, so if it says that it is a cat image, okay, then it will give you the proper output, means correct output. Okay, if it says that it is a dog, then it is a false output or a wrong output. Okay, so this type of a problem is called a classification problem. It has a binary output. Either that output is 0 or that output is 1. Clear everyone? Quickly give your response. Are you able to understand what is classification? It's not always one. Okay, so when we define the label, let's suppose that right here we have only two classes. Okay, so let's suppose that we have 1 2 3 4 5 6 7 8 9 10. So these 10 numbers are theirs. Okay, these 10 numbers are there. If you want to classify which number you are giving or on a real time basis, let's suppose that on a real time base I will provide a 5. Okay, so it match with 1 and find its correlation, it match with 2 and find out correlation. Where you will find the maximum correlation? Quickly give your response in chat. Where you will find the maximum correlation? All of you give your response. I have explained the correlation in the previous slides or previous sessions. So which number will provide you a maximum correlation? I am providing 5 as an input. 4 to 6. 5 has the maximum correlation because you are matching 5 with 5. Okay, so it will give you a 100% correlation. So automatically it classify that from 10 numbers 5 is the given input. Okay, so it classify that you have provided 5. Okay, let's take another example for classification. Okay, in our college you have seen attendance system. Okay, so biometric attendance system is there. Due to COVID we are using face recognition. Okay, we are using face recognition. Okay, so in face recognition, how your face is to be detected on a real time. Initially, what you will do, yes, for teachers, we have a face recognition system. So initially, what we will do, we will provide input to the machine learning model and train that model with the data sets of all the peoples which are present, all the faculty members which are present inside the university. Okay, so we provide these images to the machine learning model, and this machine learning model store all the features of these images. When real time, let's suppose that I am giving my face recognition on a real time through camera. So what it will do, it will match with the existing system. Okay, and where it match the maximum, that output it will give. Okay, so here, if let's suppose that this image is stored inside with this Abhi, so it will match with the this real time image. Okay, so it will provide a maximum correlation right here, and it will show that output right here. So this is the another example for classification. Clear everyone? Quickly give your response in chat. Are you able to understand it? Classification. Okay, so binary output is there in case of classification, whereas when we discuss about the regression, so regression is generally used to give the continuous data or continuous output. Let's suppose that we have y is equal to mx plus c. Okay, so here your x and y values are changing. Okay, and this m is a slope and c is a constant value, so these values are these value will not change. Okay, these are constant values, whereas this x and y value will change. Clear everyone? So when you plot something across x-axis and y-axis, let's suppose that I am taking one across x-axis, and we assume that this m is is- let's suppose that m is equal to 1 and c is equal to 0. Okay, so y is equal to x is the simple output. So let's suppose that I am taking 1 as y, so x, I am taking x as 1. Okay, so y is equal to 1. So similarly, if I will take x equal to 2, y is equal to 2, x equal to 3, y is equal to 3. So when they meet at a particular point, you can draw a line to this. Okay, the slope of this particular line will depend upon this m. Okay, and c is a constant value that is called a bias. Okay, so this is a continuous data which we are plotting right here. What is clustering? Clustering means, as the name suggests, cluster. Cluster is a similar items, bunch of the similar item is called a cluster. So when you want to draw, or when you want to create a cluster of different images, okay, you are using this clustering algorithm. Okay, let's suppose that we have a cat images, we have a dog images, we have some other elephant or lion. Okay, so there are different images of these animals, so these images are combined together in a cluster. Okay, so that particular algorithm is called a clustering algorithm. Clear everyone? Quickly give your response. Are you able to understand it? What is cluster? When you rearrange similar item together, that is called a cluster. So this algorithm we will use in machine learning. So generally three type of algorithms, okay, are available in this PyCaret. One is classification, second one is regression, and third one is clustering. You generally use pip install and package name for the installation of any library. And right here you can see you are using this and greater than, then you are using the path of the library, that is backslash dev backslash null. Okay, that means it will not give you the runtime output. Runtime output. So what is runtime output? When you want to install, you will see that this library is installed, this file is installed, something like is installed. So this process you are not going to see. You will directly see the output. Okay, when you provide this and then greater than symbol backslash dev backslash null. Okay, so the runtime output which it is showing, that will not be shown when you write and greater than this path. Clear everyone? Quickly why we are using this, give your response in chat. And we will use this command for installation of PyCaret. Okay, then we are using the print statement to display the output. So what output we want to display after installing? We will show the output that PyCaret installed successfully. Okay, now understand the next line of code. Here, when you install the PyCaret, if you want to know the version of this particular PyCaret which you have installed, you can use from PyCaret.utils import version. Okay, so this PyCaret is a library. Okay, and we are calling this utils. In this utils, all the versions and all the information related to this library will be available. So we are importing the version from this particular utils. Okay, PyCaret library, and we are showing its version right here. Okay, so you can see the version of this particular PyCaret which we have installed is 2.3.5. So this get underscore data is a function where all the values of your data sets are available. Okay, so you have to load the data from this PyCaret. Clear everyone? So click on this play button, and it will show the data is imported. Okay, and here your data set variable is initialized with this get underscore data function, and inside this function we are defining the index. Okay, so after getting all the information, you can see these data sets are divided into three categories. First is a classification, then regression, then clustering. Okay, this is the regression, and this one is your clustering algorithm. Okay, now get Boston dataset. So here what we are doing, we are importing the Boston dataset. Okay, so we defined a variable that is a Boston dataset, and we are getting the data from get underscore data as a Boston. Okay, so Boston is the particular dataset name which we will call from the PyCaret library. Clear everyone? So here we are performing some operation related to these columns. So this crime, Jadan, Indus. Okay, so all these are the boundaries for the dataset to express in, and these are the values starting from the 0 to 4. Define its parameters, and we will train the model. Okay, define its parameter and we will train the model. So how you can train the model? You have to use the sampling, you have to use the normalization, you have to use the transformation, then PCA, then handling of outliers and feature selection lastly. Okay, so first we have to do the training and testing. Okay, initially I have told you, initially I have told you that your classification model is based on the training. Okay, so let's suppose that we have one folder which contain all the images to train the model, and let's suppose that we have another block which is for testing the data. Okay, which is for the testing of data. So these two folders are training our machine learning model. Machine learning model. Okay. On a real time, when you provide some image right here to the model, so that model should be predict what you are entering inside that particular machine learning model. So is installation of PyCaret. So how you have installed it? Using these commands you have installed it. Pip install PyCaret, and after installing we have to get the version of the PyCaret. So if you want to find out the version of the PyCaret library, you can define the version of PyCaret using this. From PyCaret.utils we are importing the version, and we will display the version of that PyCaret file. Okay, after that we have seen the basics of regression. Okay, so what is the basic of regression? Firstly we will take the input. Okay, firstly we will take the input for your data. Okay, so how you will take the input? By loading the data set from the PyCaret. Okay, by loading the data from the PyCaret. So how to load the data? You have to load the data using PyCaret. So how you have loaded the data? From PyCaret.datasets import get data. This is the command to load the data sets. Okay, so when you have loaded all the data sets, you have to retrieve that data sets. Okay, so how you can retrieve the data sets? Using get underscore data, which we have defined right here. Okay, so give the heading that how you can retrieve the data. So get the list of the data sets using get underscore data. Okay, so here we are importing this PyCaret dot data set, and using get underscore data we will extract the indexes of the data sets. Okay, so we will extract all the data sets right here. So after extracting all the data sets, we have to use any one of the data set which is available right here. Okay, so for the experiment purpose we are using Boston data set. Okay, so in the Boston data set we extract this particular file, and we perform some operation on the Boston data set. Clear everyone? So how to import the Boston dataset? Similar operation we are performing right here. you can observe this Boston dataset right here. So this Boston dataset is available on line number, serial number 46. Okay. So it is a multivariate regression type of problem is there, and output variable is MEDV. Okay, and it has different classes. You can observe the heading of this column. So here instances are there, target variables are there, okay, attributes are there, missing values are there, how many missing values are there inside it. So if you have such type of data type or such type of data, you have to remove the outliers from that data. Okay, so this line number 46, you can see right here, is your MEDB or Boston dataset. Target is MEDB, and we will use this example for the practical purpose. Okay, so how you can import this data? We will use get underscore data, then define the Boston data inside the brackets. Okay, so what I am doing right here, I am defining a variable, and inside that particular variable, we will get the data, which is a Boston data set from serial number 46. Okay, everyone. I will execute it, and you will see the first top five lines of this particular data. Okay, so here is the top five rows, and here are all the columns of that data sets. Okay, so after this, we have to perform some operations related to classification, regression, and clustering. So right now, this particular data set is based for the regression model. So I have told you, regression is nothing but to give a continuously output of the data.